Okay, this is Tyler. I know that we said Zoom would probably be a better idea to use, but I'm just trying to get this done and turned in. I will download Zoom in the future so that I can use it. So if we go ahead and check, the first thing I want to point out is I have two C files inside of each one of these. And that is because I'm having an issue with compiling them. Sometimes they get corrupted just randomly, and I do not know why it keeps doing it. They are exact copies of each other. I just have a saved version in case this gets corrupted when I run it. With that being stated, I chose a centric state machine, a pattern, and a table driven. And the centric state machine you can think of as only being in one state at a time. It goes from one state to the next, to the next, to the next until it's at its destination, or until it arrives, and updates states as it goes along. And then the pattern is pretty similar, except it is a what would be a good term for it? The pattern one is a behavioral version of that. And then the table driven is the one that is quite a bit different. It runs off of a table that tells it where to go based off of where it's currently at. As far as it goes right now, I have the centric files pulled up, so I will go ahead and make those and run those, therefore we can see how they work. And as far as it goes, we have the elevator in its state, the class, the elevator, and therefore we can figure out what to do. A check for the key, the ability to request the floor, change state, check if you've arrived, and then go ahead and do things accordingly based off of where you're currently at. And then I have a couple of test cases that I can run inside of main. So if I go ahead and here and do make run, we will see that there are quite a few different outputs for this one. And the first one is going to be this right here, where I entered in an invalid floor of 5, which does not exist, so it lets you know that that floor does not exist. The next one is going to be a test where you try to go to floor 0 without a key, in which case it will tell you that the key is required for entry. And then after that, we go ahead and try that again, but this time you have the key, and you will notice that you go ahead and transition to moving down. Then you move to floor 0. It realizes that you have arrived at the floor that you're trying to get to. It opens the door so that you can get out, and then it closes the doors and it sits in idle waiting for a new input. And then another test would be to move to floor 3, where you can see rather than transitioning to moving down, it transitions to moving up. Moves from floor 0 to floor 1 to 2 to 3, realize that it's arrived, opens the door, closes the door, and waits in idle. And then there's a couple more, but I'm sure you get the idea. They're pretty well all the same concept. So at this point, I will go ahead and move back and open up the pattern-based files. And right here we have the code for the pattern. It is quite a bit longer. At this point, I did start using ChatGPT to help with the coding and getting a bit more of an idea. The centric is straightforward. I understood how it worked. The pattern, I wanted an example, so I used ChatGPT to print out an example of what an elevator would look like. And then I went ahead and went back and specified the floors and took the code that I had and tried to make it based off the code I currently had into this. And I made sure to, like I say, add the key, add the max number of floors so that would match our building. And about all that ChatGPT was used for was a reference of how they would build an elevator, and I updated it based off the centric design. So of course we still have the elevator states, and quite a bit more for where it is, where it wants to be, if you have the key, and if you don't have the key, in the ability to move down and move up. So I will just go ahead and skip down to the bottom where we have multiple different test cases. I tried to write them in here, but I was having issues, so I pulled them out and made them into voids to be ran. So if we go ahead and make run this, you will get the same concept where we have different requests. So floor 1 to 3, it is requesting 3 from an idle state. It moves to floor 1, then to 2, and then to 3, at which point you have arrived. And I did not figure out how to get the doors to open or close. That's probably happening in the background. Or, no, technically I just didn't get it to work, period. Floor 1 to 1, more or less moving from a floor that you're at to the floor that you're at. It will go ahead and realize that it is there, go ahead and move and then stay there. And then floor 1 to 0, if you don't have the key, goes ahead and tells you that you don't have the key and requests that you need the key. At which point we can get to the pattern. And like I said, the pattern is just based off this table. It works exactly like the others, but uses a table instead. Same deal, I used ChatGPT to get a reference and then went ahead and used the pre-existing code I had to make this run. So let me type in cd table, make, and then make run. In this case, it will sit there and say elevator is on floor, and it does not show that it is moving to floor, it just shows that it has arrived at the next floor and then at the next floor. So we moved, if we go to our test case, instead of inputting which floor you want to go to, it inputs where it is going, so up or down. I could not figure out a way to request just an exact floor. So you can move up and you can move down. So we see where we move up to 1, up to 2, up to 3, down to 2, down to 1, and at which point I state that we do have the key, which allows us to access floor 0. And that is the code that I have. I would not say it's perfect. If I had more time, I would try to update it so that they were a bit more similar and worked a bit better. But this is what I have, and thank you for your time.